today is all about triangles, and these activities will be aimed at age 7 to 18. So we're going to do simple things for 7 to 11, slightly more complicated from 11 to 14, and then more advanced from 14 to 18. Well, with some speciality bits for A levels for 16 to 18-year-olds, which I'm not going to cover in detail. They're in the activity pack. The activity is, the link is in the description, so please do download it. My name is Caroline from Bubbly Maths, presenting these activities provided by AIMSEC and the Aiming High website. These activities are for family learning, for home learning, and also inclusion, and they are suitable for projects during the summer, any time of the year. They're aimed at enhancing the school experience, as well as providing edifying activities for the summer, for evenings, for any time of the year, basically, if you're not a home educator normally. So now I've got to do all my jiggery pokery here. Right, that's not quite what I meant to do. Oh dear, dear, dear. Right, now, isn't quite what I meant to do. So we're going to do the jiggery pokery at 10, technological jiggery pokery. So I'm working on, I'm putting it out there to get someone technical to do all this stuff for me, so I don't have to take that moment during the transmission to, okay, well that's good. This one's come out, so I'm doing the watch party. Now all I need is to be able to play the live so that I can see your comments. That's what it's all about, is to be able to interact. And today it's working, hooray. So far, so good. It's still doing the whirly gig, but hopefully that will work out. So what are we doing? It's trifold. It's all about triangles. We're folding triangles to see what else happens. We'll do something for early years between the ages of 4 and 7, and a few at 10 o'clock. This will be quite quick because it's not about what I'm doing, it's about what you, the learner, is doing, okay? So I'm just going to get you started with a few different activities, and then you go ahead and answer the questions, and they're all in the activity pack, or the activity that you can download in the description. Now, what we're going to do is share the screen, and going to do the visualizer. There we go. This time I've got it the right way up, by the way. And I hope, letters, which way is the letters? If the letters are that way, that looks good now. I don't know what I was doing before. I don't know how many times I've done it upside down, but I think I've got it the right way up now. Worked it out. Right, now. So the first thing we're going to do is we're going to make a triangle. So any triangle, doesn't matter what size it is. I'm going to go with 20 centimeters, so it's nice and big, and you can see, wait a minute, make sure you can see what I can see. Hopefully you're seeing the visualizer. It's not clear here what you can see. Yes, okay, you're seeing the visualizer, so I'll just look at the visualizer, and then I'm sure that you've got it right. Okay, so I've got, I'm going to make a 20 centimeter triangle just because it's nice and big. And I am actually, and then let's see, it doesn't really matter what size this bit is. Let's go with something that's totally, there we go. We're going to go with that sort of angle and bring it down to there. It doesn't matter what size, and in fact this is a great activity. I just need to move the visualizer a little bit. This is a great activity to do with many different triangles, and see if when you do it you get a different result if you make a different triangle. I'm going to make one triangle. Now, how long was that one? It's going to be, the other one's going to be approximately the same, but not exactly the same. So I'm going to make a second one, which I'm going to cut out. The first one that you make, it's going to be, as I say, approximately the same. It's not going to be exactly the same. 7, I made it 7 centimeters. Deliberately not making a right angle. No right angles on this triangle, and it's all the edges are different. And the name of a triangle where everything's different is not coming to me right now. So if anyone wants to comment and tell me the name of this triangle, then that would be really good. What is it's an isosceles triangle? No, that's one where 2 edges. Whoops, I'm not showing you what I'm doing. That's one where 2 edges are the same. Which is the one where all 3 edges are different and all 3 angles are different? Whatever one that is, let's call it an irregular triangle. My brain has decided to not access that name, which is okay. To not access names is okay. If you're taking an exam, it's a bit of a problem, but other than that, it's not the end of the world. Hey, look, I made that almost identical. That's pretty cool. Just did it by eye. Okay, so I've got one cut out and one that isn't cut out. So the one that's cut out, so that's what you want to do. So you do need your ruler, you need your pen, you need a piece of paper, and let's see, what else do you need? There's a list on here somewhere. Paper, scissors, ruler, and pencils. Paper, scissors, ruler, pencil. That's what you need to do this activity. And now what we're going to do is we're going to fold, let's get this right, through A, fold through A. Okay, so we're going to fold, this is A here, this here is A, this here is C, this here is B. So we have an A, B, C triangle. We're going to fold, that's going to be our fold line, and we know where to fold it, where it's going to crease, because the base is going to cover itself. So A is the vertex. We're going to, right at point A, that's the tip of our triangle. And now we have folded it so that this, what angle do you think this is? We've folded at that point, but we've kept the base, we've lined up the base in both cases. So we've taken 180 degrees there, and then we've basically halved that angle there. If I just put a little dotted line down there. So what is each of those angles? I'm not going to draw it on there. I kind of have given you a little bit of a clue there. This is 180 degrees because it's flat. So, and I've effectively halved that. So what are these 2 angles? That's part of it. Now, the next thing we're going to do is take C. So this point here is now R. I'm going to call this R. And we can copy this in here. So we're going to bring that down. So effectively we made a line there. Boom, 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 boom. For this one, we can put A on the outside, R, C, and B. Now, if you're if you're 7 to 11, the idea is simply to draw the triangle and just see what happens. Okay, now, but everyone 7+ can do this. You might, if you're younger, you might need a little bit of help. Let's just do this and see what happens. Now what we're going to do is we're going to fold C onto R. And again, follow the base exactly. There we go. Again, we have halved 180 at this point. So we're going to boom, 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 boom. And we're also going to draw a line here. I'm going to use a ruler. In fact, I'm going to use this one because it's going to give me, it's a bit smaller. I can draw a line there. Does that come out on the bottom? Yeah. Okay, so now we're going to call this one Q, call this one T. So now we've got that here. It's a very interesting point here because if we fold that up to there, no, that's not quite the right one. Oh yes, that's the one. Yeah, when you fold that up to there, what can you say about the length of this and the length of, now that angle's a bit different, but where is Q with respect to A to C? So that's C, that's A, where is Q? You can work that out. These are all the things that we want to look at. Now, if we're up to 11 years old, that's all we need to do is we need to look at, for example, how long is A to Q compared with Q to C, and you can actually see it by physically moving it. So now I'm just going to do my, well, actually, I'm going to measure it. That might give you a clue. This helps me to get my, and then that's Q to R there. So if you all draw this, basically, I'm guiding you through drawing it. So anytime I've got a dot, that's where we've had a fold. Okay, and now we're going to do the same from B to R. So we've got C to R, B to R. Again, we're bisecting 180 degrees here. So what is that angle and what is that angle? We've got boom, 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 a fold there. We've just folded that. And then if we fold that over, then we've got, this is an isosceles triangle. That one is, and you can see it because you have folded it. So that is exactly the same as that. And this point we're going to call P there. And then the last thing we're going to fold is we're going to fold A down to R. Exactly down to R. And then we're going to mark here that we've done a fold there. Maybe a little bit. Now, I'm not the most precise person. Being very precise in this is very good. And I'm not the most precise person. So you can be more precise than me, okay? So I'm not the most precise. See, somehow that's not quite right there. And that wants to come up to there to see way right along that line to see now which is correct. That one there, it's kind of halfway between the two. I didn't get that exactly right. But the idea is that when you fold those down there, that point coincides with that dotted line and that dotted line. And if you, and I'm not going to do it. The questions are in the thing. The idea is what happens when you fold all of those down. I'm not going to reveal the surprise. It's not a secret, it's a surprise. So that's what we wanted to make, and we can play with that. The idea is the older you are, the more you're actually going to look into working everything out. Well, when you're younger, make this and play with it and find out the relationships. Like, for example, this one, that's 180 degrees now. It's got 1, 2, 3, 4 angles there. And which angles are the same and which angles are different? For example, there's a relationship between these two and these two, because that line bisects across that rectangle. You can work out, depending how old you are, what you've done in school, you can work out things like areas. Some of them you can work out. We're going to look at that. So the questions I'm asking you is, what do you notice? Again, what do you notice? As you make this, what do you notice? And as I was making that, it was all about what do you notice? Does this folding experiment tell you anything else about triangles? And why does it all happen? Why it's I'm hoping you're going to spot all the differences. We've got things like lengths being halved, and the thing is we've got half that length, but we didn't get that point there by halving that. We got that point there by meeting the point down there. So somehow by folding that over there, we've actually bisected that length. For example, that's just one little thing, but this isn't bisected on the base, is it? That's not halfway down, is it? So what I want you to do is I want you to make all different shaped triangles. I'm going to do a completely different triangle now. I'm going to make, I'll do one of my not fortes is, as you saw already, is accuracy. So I'm going to do one like this. Not going to be an isosceles triangle, because that one's going to be different to that. I'm going to make one like that. I'm going to cut this out, and I'm going to do it, instead of down the way we've done it, I'm going to do it up ways. It's a completely different triangle, maybe, without writing all the dots on, without writing all the letters on. You don't have to write the letters on. Let's see if it's true. Whoopsie. Not very straight lines. You can do a better job than me. I do get a little bit, is nervous the right word? Okay, the first thing we're going to do is draw a line straight down. Oh my goodness. I've got to do it accurately, because if I don't do it accurately, then, let's see, how can I draw straight lines all the way down here? So I'm going to use the paper to make me a set square. So I don't have a set square with me. So I'm going to use the paper to make sure, now I'm going to do it that way because that's longer, and the longer I have it, the more. So I'm matching, make sure you can see what I'm doing. I'm matching the base of the triangle with the piece of paper. Now I know that's square because it's an A4 sheet of paper. Okay, so make sure that matches exactly. Don't force it. Make sure that you're matching. There's a lot of room for error here. Got to get it exactly right. And I'm going to mark that down. Now that was a dotted line, wasn't it? So we're going to fold it. Dot, 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 dot. Okay. And then we're going to fold this over to here. Along the base. It's not, I haven't done it very well. It's not right along that base there. And it does need to be accurate, or precise, accurate and precise, because otherwise there's an awful lot of room for error here because this is so long. And then this one I'm going to fold over to there. And then see about this point here, and then also we're going to fold this one down here. It's not quite right. Because this is quite an extreme, they're very, very, very long. Haven't done that right, have I? Because there's that gap there and there shouldn't be a gap there, but you have a go. You make nice, accurate triangles and you have a go. See if this works for any shaped triangle. Now, this hasn't worked because I haven't been accurate enough. I haven't made sure that that's, so maybe what you want to do, I've got an idea. I've got an answer to it. What you want to do is start with that vertical line. You get that vertical line right, so you can do that. If you don't have a set square, you can do that with, I've got an idea. You can do that with paper. So I'm lining up this paper here. It's kind of hard to do because I've got my computer, and you can just do this on a nice clear table, but I've got my computer, my visualizer, and it's all within a small area, so kind of things getting in the way. But can you see I've now lined that up quite well. And do the same thing here. I've got a lump on my ruler there, not the best ruler in the world. Now I've got a line which is at 90 degrees. Then I can cut triangle any 2 lines, but they've got to be straight lines. Any 2 lines, and I wanted to make one that was tall and thin to make it totally different to the one that we'd made before. And I don't want to make it an isosceles triangle, but you can make an isosceles triangle. You can make it an equilateral triangle. You can do whatever you want to do. I just wanted for you to have a go at different shaped triangles. Now, with that should be more accurate. So have a go, fold that over to there, that over to there, and then when you fold that one down, it should cover it. And then what is the relationship? See if it like wherever they fold over, where is that point and what is the difference? Oh, see, look, I haven't done that accurately there. Can you see here? I haven't joined that up properly there. So you make sure that you have proper vertices on your one, because I haven't been very accurate. And with a long line like that, accuracy really, really matters. Precision and accuracy is what you need. So, right, that is essentially everything we're doing is all about this triangle. Where's the other one? This is the one I started with. Where's the one with all the writing? Lost it. Lost the plot. Here it is. Right. So now we're going to go back. Make sure you're seeing what I think you're seeing. Yay. Okay. Put that away for now. Put that away for now. And so you're looking for which angles are the same, which angles are equal, and other geometric properties. And then you can, the younger you are, the more it'll help to use colors to draw out, to mark each set of equal angles. So if you find 2 angles that are the same, then mark them in the same color. And also the lengths. So if they found 2 lengths that are the same, mark them in the same color. So what is the difference between that length? And then is there another length there that is the same length? And if so, why? Which ones are the same length within this? Because you can see there's a lot of isosceles triangles in there. There's a lot of triangles that have 2 edges the same length. And then it can take a long time to explore everything here. So if you don't want to do it all in one session, don't come back and do it at different times. There's lots of key questions in the activity. And right, so, and the kind of things you want to be looking at is, what do you notice? Why does it happen? Why does the things that you're seeing happen? Will it happen for all triangles? We've just had a go at this one, and you can see just how important it is. See how skinny that triangle is? So the problem with these big tall ones is that if you're not exactly right, if you're not exactly accurate, it's going to go all off. So you really must be very careful. But have a go at all different shaped triangles. And if it is true for all triangles, can you prove it? Does it tell you anything else about triangles? Now, I'm looking for the area. I know one thing is you might be able to really, I know for me, it finally clicked why the area is what the area is. So, and I'm going to let you discover it for yourselves, because when I saw it, it was like, oh, now I understand the formula for area rather than having to learn it. By doing this activity, I finally got it, and now I've got a visual way of remembering it, so that whenever I have to think about the area of a triangle, I can use this to remember it and just come up with the picture of it, and it makes total sense. So right, so the idea is to investigate it, and that way you can learn yourself rather than have an adult explain everything to you. Then figure it out for yourself. Just keep experimenting with it, and you think, well, can't really see anything. Well, just keep going and get a ruler and measure things and measure the angles and go, oh wait, these angles, wait, which angles are the same and which angles are different. You don't actually need a ruler or a protractor. You need a ruler. Don't actually need a protractor to measure them, because you can even just make two identical triangles and cut things out and actually move them around. Just make two identical ones, so just literally cut out several if you want at the same time. And then you can cut out little bits and test them in different areas, color them different colors. Just really, really, really have a go and experiment with it so that you really fully understand it for yourself. And then there are 4 activities within this. We're looking at the angles of we're looking to see that the angles of a triangle add up to 180 degrees. We want to see that. We're looking to see that the area of the triangle is half the base times the height, and that's the one that really did it for me. This is a great one though. Have you ever cut out a triangle and cut out the corners and put them together? But we could do that. We could do that with this one. So this one, so if you cut this one out, whoops, I'm going to do this round so that I know which angles we're looking at. And then you put them together. I don't have a contrasting color here, but if you put them together and you put them on a straight line, it shows you that, you know what this is showing you? This is showing you I really, 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 really didn't make an accurate triangle there. You know what it's showing you? That my triangle actually had a curved edge. So it just goes to show that I really didn't make, I did, I drew it, but I didn't draw it accurately enough. So this is showing you that this wasn't a triangle. One of these edges was curved. So, but that's a way, if you do make a proper triangle, this proves that this isn't a triangle because it doesn't actually make 180 degrees. But this one, you put them all in, they all come together as a flat line, and that is 180 degrees. So those are the activities. You're looking at, the older you get, now this is if you're 11 to 14 and older, the properties of reflections and enlargements. So you've got some copies here. So you've got reflections, you can spot the reflections for yourselves. And then so what you're looking for, so if you're in, certainly if you're 11 to 14, you want to see that, you want to see from this for yourself that the area of a triangle is half the base times the height. You've got guidelines in here to help you see that. And again, key questions: which angles are 90 degrees? What do you notice about the small triangles inside the big one? Which pairs of triangles have the same area? And what shape did you make when you folded A, B, and C to meet at R? Those are super, super important questions. Can you see a rectangle? Which triangles are in the rectangle? These ones here, which ones are in the rectangle? And what does this show about the area of the triangle? So you can work out the area of the rectangle. What does that show about the area of the triangle? I'm not going to demonstrate it. I want you to see it for yourself. And then, so if you are, let's see, 13 to 15, something like that, 13 to 16, you're looking at reflections and enlargements. So the fold lines are all lines of symmetry, and ABC is an enlargement of APQ. Can you see that? So the shape of that triangle is the same as the shape of that triangle, it's just larger. And then you've got a lot of reflections in there. So the enlargement on different size televisions, let's say, or different size, you might have an iPad or a smart pad or a phone, and they're different sizes, but the image is the same, just enlarged. And also you can do shadows on a wall. And the so what you want to do is talk about how, so but by playing with this, you can really, one of the things I struggled with in school was working out, like, you know, when you have to work out which angles are the same. That was one of the things I actually really struggled with when I was in school. And this activity is going to really help you with that, really help you with that, because it kind of brings it all together just in this one little triangle. Brilliant. Because the thing is, you can use triangles anytime you've got other shapes, a pentagon, a rectangle, it all can be broken down into triangles. So really being familiar with the properties of triangles helps you with all of that. So which angles are equal, which lengths are equal, which triangles are congruent, as in the same shape and the same size, just maybe reflected or something. Which triangles are similar. Similar could be they're different size, but the same shape. And then and are there any enlargements? And talk about the enlargements. And what symmetries do you see? What lines of symmetry do you see? Talk about the lines of symmetry that you see, and looking for reflections as well. And then if you are 16 to 18, you're looking at topic 4, which I spoke about at the beginning, which is, I'm just going to go find out what it is now because I've forgotten. It is to do with triangle midpoint theorem. So it's to do with, and this again is really useful. It's about the line joining the midpoints of the edges. So that, okay, I'm going to let you work out the theorem because when I'm live on this, the reason why I do what I do is because we're looking for the midpoint of that line. We're talking about the midpoint of the lines of a triangle, okay? That's what we're talking about. So we're talking about points P and Q. We haven't got the midpoint on here of C to B. So that might be something you want to investigate separately. And there might be other interesting things if you go for that. But the idea is that you're going to prove it. And this activity, you follow the activity, it's going to help you prove it. And I'm not going to do it live because I get myself in a muddle, and it's okay to get yourself in a muddle. So what you're going to do is take your time and work through it. And you've got all the guidance here. There's a massive section in the activity pack, which will really take you through how to prove it and work on the midpoint theorem. And it's got big words in there. And I'm going to let you go through it on the activity pack. Now, why are we doing any of this? It's, as you can see, it can be done on all different levels, and it's great for home learning. You can take it from quite basic, and we'll show you, well, I'll just show you now very quickly, just for the early years. You're just going to basically make a triangle, any triangle, and cut that out and see what's left and have a discussion, and then you can get your young learner to cut out any triangle, make another triangle and see what's left, and talk about the difference between that shape there, which is a triangle, count the edges, and this shape here, which is, what did Leo say? It's a square. He called it a square because it had 4 edges. He's my 5-year-old grandson, and he saw that it had 4 edges, so he called it a square. So the next thing I'm going to do with him is start getting super clear on what a square is. So I'm actually going to ask Tony for an activity for early years to get super clear on the difference between a square and any other quadrilateral. I did get him to say quadrilateral because he can say Tyrannosaurus Rex, he can say Indominus Rex or something, and he can say all the dinosaur names. So he can definitely give these names. But what he's got to get is the meaning of the names, and that's I'm going to ask Tony for an activity, because if my grandson saw 4 edges and decided it was a square, then he will not be the only one who's doing that. Right, now, so it's really suitable for all different ages, and I'm going to leave this on here because I seem to keep coming back to it. and all different attainment levels. You can really start at the very beginning, like doing this activity where you're folding a triangle to make another triangle and what do you have left. And that's really all you have to do in the earlier years. And is it possible, there's a question for you, is it possible to make a triangle such that if you fold it to make another triangle, you can make a square? Is that possible? Right, we're going to see about that. And it's just really the fundamentals. You're starting with geometry, you're working with geometry on a piece of paper, and you are at different levels taking it to a place where you become familiar with it, more familiar with the concept. And what you want to do is coming back to this activity. Take it from me, someone who really struggled in school doing maths, never really did understand about the whole relationships between all the different angles. You keep coming back to this, the points at which you then need to move on to the next bit. You keep coming back to this and you will have a really solid understanding of your triangle geometry. And as I say, the triangle geometry works for all 2D shapes, because all 2D shapes can be made to be broken down into triangles. And so it's all about the angles of a triangle adding up to 2 right angles, all three of the angles adding up to 2 right angles, the formula for the area of the triangle, reflection and enlargement, similar triangles and congruent triangles, the triangle midpoint theorem, and how to recognize what's already known. So you are understanding for yourself what you're being told in school, and then construct a proof for yourself. So that's for the 16 to 18-year-olds. You're thinking mathematically, reasoning, logically, giving explanations, applying the knowledge you have. Like, for example, Leo saying it's a square because it has 4 edges. So he's applying the knowledge he's got, knowing that a square has 4 edges. So now, and that also helps the grown-ups to maybe investigate it slightly differently, so that then Leo can see the difference between an irregular quadrilateral and a regular quadrilateral, which is a square. And then developing visualization skills to interpret or create images. And that means that you're using your imagination to to investigate a simple, it's just a triangle, look, it's just a triangle, but using all your imagination to find out the relationships between all the different aspects of the triangle. And then working in teams. If you've got somebody else you can do it with, sharing ideas, learning together. I learned so much by doing this. I'm 58 years old, so hopefully your grown-ups or your older learners might learn something too. It's very unlikely that anyone, maybe my brother, who was a bit of a maths genius, might have known it, might have known every aspect of this, I don't know. But most of us, it's very unlikely that anyone will know every aspect that's covered in this activity. And then communicate how to present information and explain to others, and also to vary it depending who you're explaining it to. And then to analyze, reason and record, especially the older learners, but everyone could do with recording things in some way or other. I encourage Leo to just make a record of what we're doing. Even if I look at it and I don't understand it, it doesn't matter, because he's getting into the practice of recording the data that we're or the activity that we are doing. So that's it for today. Thank you very much for joining us. If you are enjoying these lives, please do share the group, share the lives. And Tony asked me to do a short one. It's ended up being 40 minutes. Oh, well. That's what I felt was coming out to do it. And I just really, really, really want you to make these and just play and make lots of different triangles and make them and experiment with them. Remembering that accuracy is super important. I've just demonstrated how bad things are, how it really doesn't work if the accuracy is not good. And please share the group, Making Maths Fun for Kids of All Ages. And then there's the YouTube channels, Maths Toys, which has videos to match the Aiming High activities for home learning and inclusion, and also the Bubbly Maths YouTube channel. And those links are in the pinned post at the top of the group. And the Bubbly Maths has these lives on it, and it also has activities for soap bubbles and balloons, and we're starting to talk about maths anxiety and how it impacts home learning, or any learning really, as well as help in ways of getting rid of it, of evaporating it, so that, because there's no need for it, there really is no need for it. Maths anxiety is purely fear of something which we've all learnt. Anyone with maths anxiety has learnt that in the course of going to school, and it's really sad that anyone has it. So we're working on helping to remove it, whether you're grown up or you're a child. Okay, thank you. Let's see now, as usual, we're going to have a look, see if I can find the right spot. If anybody's joined us, we've had Aileen, oopsie, Monica Jordan, hello, Andy Davis, hello, Melissa Stanton, hello, Carol Wilkins, Llewellyn. I hope the children are enjoying this. I hope this is helpful to you. Our friend Lou, Tommy Templeton, Helen Dodd, hello, Pash Oroshi, nice to see you. Aileen, Monica, hi. John Cooper, that's Frosty. And Evelyn, hello Evelyn from Bognor. Tommy's come on again. Thank you for joining us. Don't see any comments there. And let's just see if the other one worked. See if anyone's put on any comments on the actual. No, I don't see any comments, so that's grand. So I don't have anything to answer here. That's grand. And I will now. Oh, stop share. That's it. I should have I should have stopped the visualizer earlier. As usual, you're watching a little itty bitty little me in the corner of the screen with the visualizer on. Never mind. Thank you very much. I'll see you in 17 minutes. I'll be back online with the early years. It's a very quick early years, and it's a very simple activity. But I am going to see if we can do something with a square, actually, now that I just realized. So I'm going to extend it to include a square on there. Have a great day, evening, morning, and see you next time. Thank you very much for joining.